what we have done in this section so far, Shabab, we are almost done. Now, what we are going to study today is what we mean by factoring completely, how to factor completely, and how to factor by grouping. For the first three objectives, we have already achieved them in the previous classes. The main part that we have stopped at the last time is the special factoring formulas. So these are your tools that you are going to use in factoring. When you have two terms, difference of squares, difference of cubes, difference of sum of cubes. There is no sum of what? No factoring for sum of squares. There is no factoring for sum of squares. And you have, of course, here, when you have trinomial as a perfect square. Be careful about such errors like this. Now, what we mean by factoring, by the way, when they ask you to factor, they mean factor completely. What we mean by how to know that your polynomial is completely factored. It is, this idea is similar to numbers. For example, 21. How to know that it is completely factored? It is 3 times 7. Let me give you another number. 18.
Prime factors.
18. It is 2 times 9. Is it completely factored?
No.
No, it is not, because you still able to factor 9. So this will be 2 times 3 to the power 2. Now it is completely factored. The same can be said about polynomials. And if you just replace this by numbers, a number is factored completely. It is what? When it is written as a product of a prime numbers. This is P2, section P2. This is the fundamental theorem of arithmetic. Now, when we have a polynomial is factored completely when it is written as a product of a prime polynomials. Now, if there is a question here, what should be the question now? If you want to ask a question, what will be your question here?
What is prime polynomial?
Yes, thank you. You're right. What do we mean by prime polynomial? We know what is prime number. Prime number is a prime that cannot be greater than 1, a natural number. Greater than 1 that cannot be written as a product of any other numbers, prime numbers other than itself and the 1. For polynomials, the prime polynomial is, here it is. It is a polynomial that cannot be written as a product of two polynomials of lower degree. Like what? Is x squared minus 1 prime polynomial?
No.
It is not, because we can write it as x minus 1 times x plus 1. We can write it as a product of two polynomials of lower degree. Now x minus 1, it is of degree 1. Can you factor it more?
No.
Is it prime or not?
Yes.
This is prime. Is 2x minus 6 prime?
No.
It is not, because you can factor it. You can take 2 as a common factor. Now this polynomial is prime. Okay? Is x squared plus 1 a prime polynomial?
No. Yes.
No.
Why?
No. You can't say
X squared plus 1 equals 2?
X plus 1 multiplied by x squared plus 1.
Are you kidding? Are you sure about this?
No, there is no sum of squares.
Yeah, Shabab, whatever you will think about, check. Is this correct? X plus 1 times x plus 1. What is this? This is x plus 1 all to the power 2. Is that right? You have something multiplied by itself. So it is this thing squared. And what is this? This is x squared plus 2x plus 1. Be careful. It is the same mistake that I give you a warning about this mistake here. And there is no factoring for a sum of squares. Great. So these are prime polynomials when you cannot factor more. I will mention that, of course, in terms of coefficient integers. This is what is your textbook is following. I'll mention that here, for example. Even if he didn't say Shabab completely, if he said factor, you have to factor what? Completely. Now, 2x to the power 4 minus 8x squared.
Common factor.
This is step number one always. Step number one. Factor out the common factor. What is the common factor here? 2x squared. 2 times x to the power 2. This is the common factor. Now what you will do, you will divide this by this and you will get what? 2 over 2 is 1, x to the power 4 over x squared is x squared.
Which we can do more.
Now this is also negative 4. Now did we factor?
Completely no.
We did, but we didn't factor completely.
Yeah, we need to factor.
Okay, we can factor more. So this is what? Difference of squares. So x squared minus 4, it is just x minus 2 times x plus. Did we factor now completely? Completely we factor. How to factor this?
Common factor.
Common factor, always. Common factor, x, y squared is the common factor. Notice that we take the smallest exponent when we factor. Now, can you factor more? This is difference of squares. So it is x squared plus y squared times x squared minus y. Can we factor this?
No.
No, this is sum of squares. No factoring for sum of squares. But we can factor difference of squares. So this one, it is also what? X minus plus 1 times x minus 1. Now we did factor completely. Okay? Okay, now all what we did before, ya shabab, it was for polynomials. Can we factor any algebraic expression? Not necessarily polynomial, like this. Look at these two expressions. Is this a polynomial? It is not. Yes, because the powers of x are not non-negative integers, but we can factor it. How to factor this? Yes, step number one, always. A common factor. Is there a common factor here? Between the coefficients 3, 3, 9, 6. The common factor is 3. Let me open it here in this slide. So here we are. 3 is the common factor. Now what about x to the power 3 over 2, x to the power half, x to the power negative half? X to the power a half. Why? What we do here? Look, why here we choose x to the power 1, not x to the power 5? The lowest exponent, the smallest. What is the smallest exponent here? Negative a half. So here we will take, what is the common factor? It is x to the power negative a half, and we will open brackets. Now 3 over 3 is 1. This over this, now you will do x to the power 3 over 2 over x to the power minus a half. And this is indeed what? You can think about it this way, of course, but it is in fact just about using the distributive property. So it is 3 over 2 minus a half. So it will be plus a half, which is what? X squared. So we will have here x squared minus, this is the minus, 9 over 3 is 3. X to the power half over x to the power negative a half. It will be x to the power a half minus a half. It will be a half plus a half, which is 1. Plus, this plus 6 over 3 is 2. This over itself is 1. Now, did we factor? Yes. Did we factor completely? No. Maybe. It is about, it depends on this. Can we factor this trinomial? It is trinomial. It is not necessarily to be perfect square. If it is perfect square, this is perfect. But if it is not, we can also, maybe we can factor it as trinomial. So this common factor as it is, and here we will have what? Let's think about it. We need two numbers. The product of them is positive 2, and the sum of them is negative 3. Negative 1 and negative 2. Check. Don't go to the next step. You can check. You can check your solution. Also here, you can check, ya shabab. If you multiply this by this and this by this, you should be able to go back. You should go your original expression back. Great. So this is the detailed solution. Now, what about this one? Can you factor? How many terms we have here?
2.
Mainly. This is one term. This is 2 terms. We have 2 terms mainly. Is there a common factor?
Yeah.
What is it?
2 plus x to the power 3.
You still have the same problem, by the way. The lowest, which one is smallest? Negative 2 over 3 or third? Negative 2 over 3 is the smallest. So we will take it factored out. Is it the same if we have a shabab here x plus 2 to the power third? It is the same because addition is commutative. But if it is minus, no, it is not the same. You should have here y to the power, the same. So we will factor it out. You can factor it to the right or to the left, by the way. You may write it here on the left, on the right, like what we did here. Now, what we will do, we will factor it. So when we factor it out, we will open brackets here. Now this over itself, what is remaining? 1 times x, which is x. This is plus, this plus here. This over this, it will be what?
-1.
2 plus x to the power third minus to third. So it will be minus negative, it will be plus, it will be 1. Now we will use the associative property for addition. What is this? X plus 2 plus x, it is what? It is 2 plus 2x. And this is, of course, the same. Did we factor completely? We still able here to factor. So we will factor 2 out. Okay? So you will factor it out. It will be here. Usually we prefer to write it at the beginning. And here we are. Here it is. The multiplication is commutative. You can write the 2 here, but usually we write the coefficients at the beginning of the expression. Great. Everything is okay, Shabab?
Yes.
So if everything is okay, you should be able to solve this recitation. Yes?
We cannot take x as factor.
Where?
Plus,
Where?
there was 2x and x in the other term, right?
This x and this x?
It's the power.
The previous two.
Where? Here?
No, yes, here.
Here?
Yeah, we take 2 as a common factor, right?
Yes.
Okay, why we can take x as a common factor?
Where x is a common factor? Do you know what we mean by a common factor?
Yeah, but sharing in 2.
Yes. Oh, no. You need to explain that for me. How to factor out a common factor? So usually what we do when we factor out the common factor? We have what? We have two terms or more. And there is a common factor between them. Tell me, where are the 2 terms that they have common factor? Tell me where they are. Is this a term or a factor? Is this a term or a factor? A term, when you have plus or minus between them, like this, you have, this is a term, and this is there is a common factor between them. This is a multiplication. When you have x times x, you will take x here as a common factor. It is a multiplication. There are factors. You need to go back and revise the questions, the examples of the factoring out the GCF, the greatest common factor. Now you should be able to factor this completely, Shabab. Let me pause the recording and I will just review the grades of some of the grades of quiz number 2. You will go back and I expect that you will be able to do this because it is similar to what we did in the previous slide. So check your answer now. If you factor check, is this what you obtain? Check your factoring.
That's right.
Good. So easy, Shabab. What is the problem? The idea is about how to factor out the common factor. Now let's look at the coefficients. We have here a half and we have here 3 over 2. This is the common factor, if there is a common factor between half and third, 3 over 2. A half, yeah, Shabab, here you have a half, here you have 3 halves. So here, in fact, you have 3 times a half, which is, of course, here, what is here and here? What is the factor that is in both terms? A half. So we will take a half as a common factor. Now, x to the power negative a half, x to the power half. X to the power negative a half. Now, 3x plus 4, 3x plus 4, which exponent we will consider? Negative a half. So now we will open a big bracket. Now we will start dividing each term by the common factor. Now this is, ya Shabab, this is the plus, this is the sign, this is the second term, this is the first term. The term here, it is consists of factors. Okay, now the first term over the common factor, what you will get? A half over itself, 1. X to the power negative half over itself, 1. This over this, So you have now 3x plus 4 to the power a half divided by 3x. If you want to think about it this way, in fact, it is just a distributive property. It is 3x plus 4 to the power a half minus a half, which will be what?
1.
Which will be 1. Okay. Now this plus
Same sign.
the second term over the common factor. 3 over 2 divided by a half. What it will be? 3 over 2 multiplied by 2, which is what? 3. So we'll have here 3. X to the power a half over x to the power minus a half. It is 3 to the times x to the power what? 1. It will be a half minus a half, which will be x plus a half, which is 1. So this is x to the power 1. Now this factor over itself is 1. That's it. You can, ya shabab, check your factoring. Don't go to the next step before check. If you multiply this by this, are you going to have this term? Check that. If you multiply a half, this is a half x power. This one plus what this one, it will be a half. Okay. Multiply this by this. Are you going to have this term? So check. Mistakes and errors are not allowed here, shabab. You can check that you are right or not. Okay. Now, what we can do? Can we do something more?
Yeah, we can.
Yes, for the common factor, of course, we can do nothing. But of course, if you look at this, you can here have 3x plus 3x. What is that? 6x by using the associative property for addition.
And there is also a common
We can factor here more.
Yeah.
What is the common factor here?
2.
It is 2. So you will have here 3x plus 2 times this, a half x to the power minus a half, 3x plus 4 all to the power minus a half. Now, this 2 can be simplified with this 2, and you'll have this puzzle. Okay, this, of course, can be cancelled with this. Okay, let's go to the last part of this section, which is factoring by grouping. What is factoring by grouping? Why we need it? How to use it? You should always ask yourself about these 3 questions. Always, when you have any concept, what, why, or you can, instead of why, you can ask yourself when I need it, and how to apply it, how to use it. This, if you can answer these questions, you understood the concept. Now, when a polynomial has more than 3 terms, it is sometimes can be factored by what? By grouping. What is grouping? It is clear from the name. You will divide the terms into 2 or 1 or 3 groups. It depends. Okay. And this is indeed the opposite of applying the distributive property. Look at this. I remember that I mentioned this for you in P5. I told you in P5, when you multiply binomial by binomial, this is what you will get at the end. The question is how to go back, how to go in the opposite direction. If you have these 4 terms, how to factor them, how to write them as a product.
Separate them.
So it is not a separation indeed, it is grouping. It is called grouping, but be careful when you group, because I noticed that some of you, they forget to write plus. If you didn't write this, it means you did factor and this is wrong. So when you factor or you group, just it is for you to use the associative property indeed. You are just taking these together and these together, but don't write brackets if it will confuse you. Okay. Now just look at this as they are. So this step, you can skip this step. Look at these. Is there a common factor between them? Yes, it is A, factor it out. Now, is there a common factor here also between these 2 terms? Most importantly, now, this is group number 1. This is group number 2. Is there a common factor between these 2 groups? If there is no common factor between them, or you cannot factor them, you did nothing. You need to regroup them again. Okay? So now we are lucky here because there is a common factor between this term and this term. And it is x plus y. Factor it out, you will have a plus x. You can check. If you multiply this by this, you will get this. If you multiply this by this, you will get this, and you can go back.
So factored by grouping is the opposite of distributive.
The distributive property. It is, in fact, factoring in general is like that.
It's the opposite.
Yes, yes, you are doing there in the other way. It is like when you have difference of squares. let's see how can we factor this, of course, completely, even if he didn't mention. How many terms we have here? 4. So it is natural to think about grouping. Now, how to group this? It is, of course, also natural to take the first term and the second term. If it works, okay. It doesn't, you can change. Now, let me show you here. If you take the first one and the second, the first term and the second term, what will be the common factor between them? X squared, and what you will get after that? X plus 1. Now here plus, we still have plus, ya shabab. This is the second group. Plus this plus, we have 4 as a common factor. Now, if it works, I will have a common factor. Is there a new common factor now? Yes. So we are lucky. It works. So now what is this? It is X plus 1. You can factor it out on the right or on the left. You can write the result here or here. It's up to you. Okay. Now what is remaining after factoring out X plus 1? X squared plus 4. Can we factor X squared plus 4 more? It is a sum of, we cannot factor it, of course, with real coefficients, and of course, more importantly, with integer coefficients. So what about, ya shabab? I have noticed some of your colleagues in the previous section, they suggest several ideas about this factoring. They said, why we didn't take X as a common factor here?
Well,
If we did, look what will happen if we did that. So what? Ask yourself, so what? What is after that? What you can do after that? You cannot. This is not factoring because we still have term. Okay, other ideas from previous sections also, they said what? And it is true, by the way. They said, oh, this, what we have here, it looks like a perfect square. And it is indeed. This is X to the power 3 plus, what is this? X plus 2 all to the power. It is right. It is perfect square. But what is after that? What you can do after that? You cannot factor now. So it is important to decide from the beginning and choose the right choice and the right grouping for your. Okay, what about this one, Shabab? Easy also. Try the first 2 terms, then the third. If it is not, you can reorder, ya shabab, the terms, but keep them with the same sign. You know that the addition is commutative, but of course the subtraction is not. So be careful. So now what we can do? Let's try this. Between the first term and the second term, what is the common factor? X squared. Open brackets. What you will have here? X minus 2. Is that right? Now, we should have something like this in the second group. Now, the second group is what? Minus 3x plus 6. What is the common factor between 3x and 6?
2.
If we take, 2, between 3x and 6, it is 3. Between 3 and 6. If you take positive 3, look, if you take 3 as a common factor, what you will have? Negative over positive is negative. 3 over 3 is 1, and you have x. Positive over positive, positive over positive is positive, and you will have here what? 3, 2. Now, is this, of course, the same as this? It is not. This is the negative of it. Indeed, you should take here negative 3 as a common factor. So here, take negative 3 as a common factor. If you take negative 3 as a common factor, negative over negative positive, 3x minus 2. Check negative 3, it will be negative 3x. Negative by negative is positive, 3 by 2 is 6. Now you have a common factor between the 2 groups. Now factor it out to the right or to the left, it is up to you. Now factor it out, what is remaining here? X squared, and this is the negative that we have here, minus 3. Now the question is, can we factor this more?
No.
Why? It is difference of squares. But this is not a perfect square, 3. Usually, according to your textbook, by the way, we can write it as x minus square root of 3 times x plus square root of 3 times x minus 2. And you cannot do more. Indeed, according to your textbook, the coefficients are integers, so we will stop here. But if you want to continue factoring, you can, because it is difference of squares, but this is not a perfect square. 3, it is not like 4, 9, 25, and so on. Excellent. Yes.
In courses after, like
Yes, you can. Yes. Even in next section, we will do that. Yes. But when you factor completely, we have it like polynomials with this of this type. Okay, these are some solved exercises. I will leave them for you, but please practice. Don't read the solution. Try to practice before reading the solution. Practice. It is for practice. I expect now you will be able to factor this completely. Please. Again, it is about what we did in the previous example. Factor this. This is a recitation exercise. You can raise your hand if you have an answer. Done? Let me see. Excellent. All right. You see? No, there is a mistake here. How you did that? What is the steps? Step number 1, 2, 3. You did a mistake. Be careful. It's not correct. True. True. It is just in maybe 2 or 3 steps, Shabab. Let me see. Right. All right. Correct. Correct. Okay. For the others, Shabab, for the others, please check your answer. I will show you now the answer, and you can check your answer. Check your answer. Is it like that? If it is like that, you are right, and you should be proud of yourself. Now, what you need to do, Shabab, here, of course, try. There is not only one method to factor, by the way, by grouping. Sometimes you may have more than one method, but usually we'll try to take the simpler one. What is the idea? Can you tell me what you did?
I take the groups y about 3 and y squared.
So this is called reordering the terms. So let's reorder the term, but keep in mind that the signs should be the same. Don't change the signs. So is it okay if we write it like this? Y to the power 3 minus y squared plus y minus 1. What I did, just I reordered the addition is commutative, no problem. Now my plan to make this one group and this one another group. Okay. Now in the first group, there is a common factor. What is it? Y squared. Now what you will have after that? Y minus 1. We are lucky. Here it is. This is y minus 1. Just write it inside the brackets to recognize it, but no need even for the brackets. Now there is a common factor between the two groups. What is it? Y minus 1. Factor it out. What is remaining? Y squared plus. That's it. If you factor, some of you, I noticed that they factor this as a difference of what? Cubes. It's okay. And here take -1 as a common, a -y as a common factor. And you can factor it, but it will be a little bit longer. Try that. Try it at home. Okay. Now, this is the summary of the section, Shabab. These are, of course, the main tools that you have. The key terms. Remember, always keep in mind that factoring can be checked by multiplying. And I will give you here an algorithm. You can think about this slide like an algorithm of factoring. How to do factoring. To factor a polynomial, always start with what? With the GCF. Factor out the greatest common factor. Okay, then look at the number of the terms. If you have two terms, what are the options that you have if you have two terms only? Difference of squares, difference of cubes, sum of, there is no sum of squares. Okay, sum of cubes. And ask also yourself always, can I factor more? Did I factor completely or not? Sometimes you can. Now, if you have three terms, you should think about trial and error, the X method, the scissor method. When the polynomial, when you have trinomial with a equals to 1, or when you have a is not 1. Finally, if you have more than three terms, 4 or more, okay, you may think about what? Grouping, and we will learn also some advanced methods in chapter 3. Okay, Keep in mind, of course, يا شباب, that polynomials that cannot be factored, they are called, of course, prime. So maybe you are factoring a prime polynomial, and of course, this may happen. Factor this completely. How to factor this? How many time we still have? 10 minutes. So I have solved an old exam question like this for you in the slides. Let me show you the old exam question that is related to this. The same idea. Also, this question I have repeated in P5 and in P6. You can solve it as a P5 problem, simplifying, or you can use factoring. Now, if you want to use P5, ya shabab, what can you do here about this one, for example? Expand the square. So you can write it as what? 1 plus 2 over x plus 1 over x squared minus 1 minus 2 over x plus 1 over x squared. Then simplify, you will get something like this. You will get 4x. Simplify, you will get 4 over x. But this is not what we can do here. What we want to do here. This is not what we want. If it is a written quiz, for example, you have to do it as factoring. I will consider this 0 for you, because I'm not asking for simplifying. But of course, when you have a question like this, and this is the final answer, he's not asking here to factor. He's asking you to do what?
To get the result.
To get the final answer in a much simpler way. So you can use factoring, and you can use, of course, simplify. So how to use factoring here? Just let me show you. Difference of, so you have here a squared, b squared. Okay, this is a, this is b. So what it will be? A minus b times a plus b. So here it is, ya shabab. This is a minus b, a plus b. Now simplify. 1 minus 1, it will be 0. X over y plus x over y, it will be 2x over y. Here you will cancel x over y with x over y. You will have 1 plus 1, 2. Now it is factored if you want to factor it. If you want to simplify it, 4 over x, 4x over y. You can do the same here, ya shabab. So I will leave it for you. Factor it as a difference of squares, or simplify. How to factor this? Yes. Good idea. So it is not a good idea. It is a bad idea indeed. A plus b is not a common factor. It is not a common factor between all the terms. What you will do after that? If you take a plus b as a common factor, what you will do for this term after that? Yes.
We can say a plus b equals 2x.
Yes, this is the sense that I want you to have, ya shabab. This is a plus b, this is a plus b. So this is 2x squared plus 5x minus 3. What is x? You should mention here what is x.
X equals
X is what? A plus b. So now it will be so easy. If you need to use substitution, in fact, you can solve it without if you want. Now this will be equals to what? Trinomial by trial and error. 2x squared, it is 2x times x. Now I want the sum to be the sum of the products to be 5, positive 5. So we will use 3 plus 1 positive. I want the bigger product to be positive. Here it is. You can do it as quick like that. Just you need to practice more. Check. Don't go to the next step before checking that your factoring is right. Because if you did something wrong here, everything after that will be wrong. So now what we will do? What is x? Substitute back. So it is a plus b. And when you replace x by a plus b, put it inside brackets. A plus b plus 3. You can also put it inside the brackets, even if you have positive, no problem. Now in the next step, it will be 2a plus 2b minus 1. And here we have a plus b plus 3. Can you factor more? Can you simplify inside the factor? That's it. And this is the answer. This is what we have. This is the answer. You can check your work at the end. Now, can we factor this? How to factor this? Yalla, tell me.
common factors first.
Common factor first. Always keep this in mind. Step number 1 is common factor. Is there a common factor here?
8.
What is it? Only? Only 8. So what is the now after factoring 8 out? What we will have? Now, how many terms we have? 2. We have 2 terms. When you have 2 terms, ask yourself, is it sum or difference? Difference of cubes or difference of squares? Cubes. So what is the cubic root? This will be what? You remember the formula, a cubed minus b cubed, it is what? It is a minus b times a squared plus ab plus b squared. Just you will apply this formula. Now, what is the cubic root of r cubed? R. The cubic root of 8, 2. The cubic root of 2 to the power 6, 2 squared. Now you will square r, the opposite sign. If it is minus here, it will be plus 2rt squared plus 4t to the power 4. Is that right? Check your answer. Let's go more. How to factor this? I will give you 1 minute. 1 minute to think about it. 1 minute and give me the right answer. This is usually how the old exam question will be in this section. He will give you one of the factors. So he will not ask you to give all the factors. He just said one of the factors of this expression is. So which one of them will be a factor of this polynomial? A, B, C, D, or E? You have an answer? Good. What is it? A. Let's see if it is A. C. We will see if it is C. Why you are not trying? Try. Yes. A. Great. We have 2 votes for A. 3 votes for A. We have 1 vote for C. Ask yourself the algorithm. Do you remember how many terms you have? Do you have a common factor? No. So go to the next step. Always ask yourself like this. Is there a common factor first? There is no common factor. Ask yourself how many terms? 3 terms. So think about it like trinomial, like perfect square, like. Yes. C. We have 2 votes for C. A, we have 4 votes for A. Yes. Show me your solution. Great. Let me see. Wow. It is x to the power 4, not x to the power 2. You are right, partially right, by the way. You have many English letters. Why you are using x again? The right answer is A. The answer is A. Why it is A? Look at Shabab, you have x to the power 4 plus x squared minus 2. Look how I will solve it, and I'm sure that you will do it like this also in the future. Maybe not now, but you will do it later. Look, it is trinomial. Let me try. What is x to the power 4? It is x to the power 2 times x to the power 2. Is that right?
Yes.
Now, what is 2? I need 2 numbers. The product of them is -2, and the sum of them is +1. +2 minus 1. Now I can factor this. Can we factor this? No, we cannot. Now this one we can factor it. It is x minus 1 times x plus 1. Now I'm sure that you can do this by substitution. It is easier for you to do it by substitution. How? You can write it as y minus 2. This is y, this is y squared. What is y in this case? Let y equal x squared. So you will notice that here you have something and here you have the square of this thing. So if you put this as y, this will be y what? Y squared. Now here you can factor it. This is what you did, but with x. Don't use x, ya shabab. When you substitute, this is a common mistake. You say let x equal x squared. No, this is not. You have many letters. Use other letter other than x. Okay, now this is of course the same. It is y plus 2 times y minus 1. Now substitute back. Here we are. Now you can continue factoring. And he will give you one of these 3 factors, not all of them, of course. Now, do we have time? We don't have. It is very interesting if you can solve this one. Try to solve this one. Even if we have time for that, you can try it at home. Of course, it is what? Ask yourself the first question. Is there a common factor between all the 5 terms? There is no common factor between all of them. There is no. So you have 5 terms. So what you need to do in this case?
Grouping.
Grouping.
Yeah.
Of course, we are doing factoring, but factoring by what?
Grouping.
By grouping. This is the question now. How many groups you need to do? Every group consists of how many terms? How can you do that? It is an interesting question, Shabab. I will leave it for you because of the time. That's it. This is the end. I will leave it for you to practice, and if you cannot solve it, I can help you with it later. But let me also show you, these are some additional solved exercises, and also there is I added here an A+ for A+ students, a question here, similar to what we did today in the recitation, but it is it cannot be factored like that. You need here 2 numbers. The product of them is 4, and the sum of them is 3. Positive 4, positive 3. So try to solve this. Try before looking at the solution. The solution is there, but don't read it, please. Try to practice it before. Okay, there are many questions, also many old exam questions in this section. See you tomorrow, inshallah. We will start tomorrow P7.